to find the GCF and the LCM using the ladder method. Remember, the GCF stands for the greatest common factor and the LCM stands for the least common multiple. Let's get started. So for the first example here, I have 24 and 42. So what I want to do is I want to actually make a like a little like an L, or like an upside down division problem there. So what I'm looking for is, if I have 24 and 42, I'm looking for the smallest prime number that goes evenly into both of those numbers. Now remember, a prime number is a number that only has two factors, one and itself. So the smallest prime number is 2, and it just so happens that 2 goes into both these numbers because they're both even. So I'm going to write the 2 there. So now, like I said, I'm going to do some division here. So 2 goes into 24 12 times, and 2 goes into 42 21 times. Okay? So now you can basically forget about this 24 and 42. We have two new numbers. We have 12 and 21. So same thing. I want to look for the smallest prime number that goes into both of these numbers evenly. Now, again, the smallest prime number is 2, but 2 doesn't go into 21. So the next prime number was 3. And 3 does go into both these numbers. So let's put a 3 here, and 3 goes into 12 4 times, and 3 goes into 21 7 times. Again, two new numbers. I have 4 and 7. However, there is no prime number that goes evenly into both of them. Now you might be thinking that 1 would work. Well, 1 isn't a prime number. Again, 1 only has one factor, just 1, whereas prime numbers have exactly 2. So I've gone as far as I can go here. So basically, let's find the GCF. So the GCF, I have all the information that I need right in front of me. Now the GCF, I'm basically just going to look on these two numbers on the side. Okay? These two numbers that I used as prime numbers that fit into the numbers in here. Right? And I'm going to multiply them together. So 2 times 3 gives me 6. So the greatest common factor of 24 and 42 is 6. So that means that's the greatest number that fits evenly into both of those numbers. Okay? Now let's find the LCM. So the LCM, what I have to do here is I'm going to make a big L, all right, around the problem. Okay? Now look at all these numbers that I created here on the outside. They're outside these boxes. There's a 2, a 3, a 4, and a 7. So what I'm going to do is I'm going to add them to, I'm going to multiply them together. So 2 times 3 is 6. 6 times 4 is 24, and 24 times 7 is 168. All right, so the LCM of 24 and 42 is 168. All right, let's move on to the next example here. I have 18 and 24. Again, same thing. Let's make a little L around these two numbers, and let's find the smallest prime number that goes evenly into both of these numbers. All right, and that would be 2. Again, it's easy to start out with the smallest prime number, which is 2. These are both even numbers, so it works. 2 goes into 18 9 times. 2 goes into 24 12 times. All right, so now I have two new numbers, 9 and 12. And if we start again at 2, see if that works. It does not work because 2 doesn't fit evenly into 9. Next prime number is 3, and 3 does work because 3 goes into 9 3 times, and it goes into 12 4 times. But now I'm stuck here again because there is no prime number that goes evenly into both 3 and 4, so I'm done. All right, let's find the GCF. The GCF, we're just going to take the two numbers on the outside here. All right, 2 times 3 is 6 again. And then for the LCM, I'm going to make my big L for LCM. And I'm going to take all these numbers that are on the outside of the boxes, all right, in this little strip here. So 2 times 3 is 6. 6 times 3 is 18. And 18 times 4 is 72. So that means the LCM of 18 and 24 is 72. And that's it. That's using the ladder method, finding the GCF and the LCM. I'm going to post a video. If you look on the top right, there's a link to finding the GCF and the LCM using the prime factorization, using factor trees. So if you prefer that way, check it out. Thank you very much for watching.